Tasty, Toasty Space Tomatoes. This is a presentation of my Genes in Space proposal. Part of running a long-term space mission would be feeding everyone. One of the best ways to do this is to grow your own food, eliminating the need for extra support from home and really heavy payloads to carry the necessary food for long-term missions. In space, we'd be in a zero-gravity environment. We know that zero gravity can have negative effects on the human body. My goal is to test what effects it will have on our ability to grow plants or food in space. On Earth, plants grow towards the light, but use gravity to know how to orientate the rest of the plant. The stress of something like drought or intense temperatures put on the plant could slow its growth, inhibit fruit production, and cause the stomata to close, slowing or inhibiting the process of photosynthesis. Stomata are tiny pores in the plant's leaves that, when open, allow the plant to exchange gases during photosynthesis. The stomata also close to protect the plant. Because of this, the stomata often close when the plant is under stress. I wish to test, will the stomata close in response to the stress of zero gravity? There are genes called mute genes that allow the stomata to open and close But my genes in space proposal is to monitor the genes that regulate stomatal activity, to see if and how they are affected by the stress of zero gravity. To learn about stomatal function in zero-gravity environments, we would plant tomato seeds on Earth and on the ISS with similar environments, and record their growth and activity over about 80 days, which is the time it takes for a tomato plant to grow and produce fruit. If we monitor the outward growth and appearance of the plant, and also the internal on a microscopic level, we will have a better idea of how the plant is responding to the stress of zero gravity, and whether any response is related to stomata or because of something else. I hypothesize that the microgravity of space will create stress for the plant, leading to an increased need for stomatal activity. This will in turn lead to decreased mute gene activity in the tomato plants on the ISS versus tomato plants on Earth. In high-stress environments, the additional stress of zero gravity will cause mute gene expression to decrease, causing decreased activity in the tomato plants. The reason why I chose tomatoes is because tomatoes offer a source of food and are relatively healthy. And though they do not account for all the vitamins a person needs throughout their day, they do provide calories. Tomatoes also grow quickly relative to other garden plants, making farming them efficient and a good test to observe the effects of a microgravity environment. Figuring out whether and how we can grow food in space is an important step to take if we're going to have long-term missions or even permanent settlements in space. My proposal talks about one way we can start to gain this important knowledge.